Hey guys, this is Geometric Shapes, pages 269 to 270 in your arithmetic book. All right, so we will continue our lesson on geometry. Okay, so in this lesson, I'm just going to be going over different geometric shapes and how we can label them and what they're called. So, all right, let's get started. So, first one we're going to learn about is called simple closed curves. So these are pretty much any shape with no point of intersection. It does not cross itself and ends at the same point that it began. So that might be a little bit confusing. Let me show you some examples. Pretty much most shapes that you can think of fall under the simple closed curve category. For example, a triangle or a circle or a square. These are all considered simple closed curve, okay? Don't let the word curve confuse you. The shape does not need to have a curve in order to be considered a simple closed curve, all right? So even though this triangle here doesn't have a curve in it, it's still considered a simple closed curve shape because at no point none of these lines intersect with each other, and it does not cross itself, and it ends at the same point that it began. That might be a little bit confusing. So when I talk about how there's no point of intersection or it does not cross itself, that means none of these sides here ever cross itself. Okay. If I drew it like this, all right. So this here, at this point spot here, my shape here crosses itself. All right. You see how it kind of right here across it's intersecting itself here. It crosses paths with itself. So this would not be considered a simple closed curve. But this would, because none of these lines here ever really cross each other. And when I say that it ends at the same point that it began, what I mean by that is that okay, let me zoom in a little bit more. Let's see. All right. When I say that it ends at the same point that it began, so if you recall, when I drew this triangle here, I started up here, went down, right, and then back up again. You see, I started and I ended at the same spot up here. Okay, I started here, went down, right, and left. Okay, so if I drew it this way, right here, so this would not be considered a simple closed curve because I started at this point here, I went down, I went to the right, and went back up. And I did not stop at the point that I started with. Okay, I ended at a different spot. So this would not be considered, the shape here would not be considered a simple closed curve because I didn't end at the same point that it began. All right. So let's go over a little bit more examples. So in any shape, it could be this shape here, it could be a diamond, it could be hexagon. These are all simple closed curve. Okay. Even something as weird as this. This is a simple closed curve too. I don't know what shape this would be, but there's at no point does any of these lines intersect. But if I drew something like this, would this be a simple closed curve? No, okay, because you see at this point here, our lines cross each other, all right? Okay, so that would not be considered a simple closed curve. All right, so let's see, I'll erase these here. All right, let's go to our next concept. Number 2, polygon. A polygon is a shape made of straight lines, line segments. So if you remember in our last lesson, we talked about line segments. It looks something like this. A line segment has a beginning and an end, okay? Usually you have points at the ends, but doesn't necessarily have to be. So this is as opposed to this, right? When we see these arrows, we know that this means that the line stretches on and on and on and on and on forever, right? It'll keep going on and never end. All right. So this is a line. It's not a line segment. All right, but we know that when we see these dots or these points at the ends here, we know that this means this line That's as far as it will go. So a polygon is a shape made out of straight lines. All right. So for example, you know, so let me erase this. Same thing. A triangle is a polygon because all of the shapes here are made out of straight lines. Okay, I know it's not very straight. All right, a square is a polygon because it's made out of straight lines. All the sides are just straight lines or line segments. Here, later on, we'll learn that this is called a rhombus. All right, so a rhombus is a polygon because all the sides here are just straight lines. Would a circle be considered a polygon? Is the circle made out of straight lines or line segments? No, right? So this would not be considered a polygon. Okay, what about this shape here? A cone. Would this be considered a polygon? See this here and these sides are straight, right? But is this side here straight? No, it's curved. So this would not be a polygon. A polygon can only be made of straight lines, any shape. So it's something as weird as, this shape here. This is a polygon because it's made out of only straight lines. All right. So just remember, a polygon cannot have any curves in it and just made out of line segments. All right. So draw this example here. So this is a polygon made out of just straight lines. Okay, so our next concept is triangle. You guys know what triangles are. It's a polygon with three sides. So if you recall, we just learned about polygons. So made out of straight lines and with three sides. So a triangle is made out of line segments, straight lines, and it can only have three sides in it. So obviously, this is a triangle, right? Made out of only straight lines. And 1, 2, 3. It has three sides. So yes, this is a triangle. And this would be considered a triangle too, because it's made out of only line segments, and there's only 1, 2, and 3 sides, right? 1, 2, 3, yeah. And let's see, it could be anything with three sides and straight lines could be a triangle. So this is also a triangle because it has 1, 2, 3 sides, and it's all line segments. Is this considered a triangle? Okay, it's a polygon made out of straight lines, but are there three sides? Let's count 1, 2, 3, 4. Nope. There are three sides to this shape here. And yeah, so that means this is not a triangle because triangles can only have three sides. Okay, what about this shape here? Is this considered a triangle? No, right? Because why? Yeah, it does not have just three sides. It has 1, 2, 3, 4 sides to it. So this is also not a triangle. All right, erase that. Here's our next one we have to go over is let's move this down. Quadrilateral. It's a polygon with 4 sides. So similar to triangles, but this time instead of just 3 sides, it can only have 4 sides. So example of a quadrilateral, you know what? Here, let me draw some examples of quadrilaterals for you. Here's one example here. This is a quadrilateral polygon, and it's polygon made out of only straight lines, and there's only 4 sides, right? 1, 2, 3, 4. So this is a quadrilateral. This shape here, rectangle, is also a quadrilateral. A simple square is a quadrilateral. This shape here is a quadrilateral. All right. And this shape here is a quadrilateral. Let's try to do straight lines here. Okay, yeah, sorry, I know it's not perfect. Okay, doesn't have to be perfect. All right. So there's actually special names for all these shapes too, because they're all quadrilaterals. They all have four sides, and they made out of just four straight lines or line segments. There's special names that we can call these. So this first one here, this first shape here, is actually called a parallelogram. This is a parallelogram. And a parallelogram, the sides, opposite sides will never cross or intersect. Okay, so this is a parallelogram. So if you look at our sides here in a parallelogram, well, the really important part of this word parallelogram is parallel. If you recall, do you guys remember what parallel means in our last lesson? Well, something is considered parallel if the lines are going the same direction and they will never cross. So these two red lines here, even though, so these two red lines are parallel to each other, because even if I stretch out this line here forever and ever and ever and ever, and if I stretch out this line here also forever and ever and ever, it will never, these two lines will never cross each other, okay? Even if it goes on for 500 miles, it will never cross each other because they are parallel to each other. So this is, but if I had something like a line going this way and another line, let's say, going this way. So are these two lines parallel to each other? No, right? Because if I drew a line straight out, I can see that they eventually, at some point, will intersect or cross each other. But these lines are not parallel to each other. All right, so a parallelogram is a shape. It's a quadrilateral. So, it's a shape with four sides, and the opposite sides never cross each other. So I'm gonna copy this and bring this over here. Okay. So my opposite sides. So this side here, this side, and this side, they're opposite from each other, right? They're across from each other. And I know that the side up here and the side down here in the bottom, they're also opposite of each other. So if I drew a line, extended this line out, I can see that, these two lines opposite from each other, sides, if I extend it out, they would never cross each other. They're parallel to each other. Same thing for the bottom and the top. If I extended these lines, and I kept going and going, at no point would they ever cross each other. So that's what a parallelogram, right, is, okay? Is when the opposite sides will never intersect. They're parallel to each other. Okay? So let's go over this shape. You might recognize this shape. This is called a rectangle. Rectangle. So you might be wondering, what makes a rectangle rectangle? Well, pretty much a rectangle is also it's a parallelogram, all right? So we just learned about parallelograms, meaning the opposite sides, they will never cross each other if we extended them. So it's a parallelogram. Parallelogram, that's a hard word to say. With four right angles. All right, so if we remember our last lesson, we learned about right angles, okay? All right, so what is a right angle? All right, so let me do something real quick here. Sorry. So what is a right angle? I'm going to copy this thing here. Paste it down here. If we recall, right angles are, it's the angle that goes 90 degrees. So this is an example of a right angle. Okay? Because we have a line going straight up and down, and we also have a line going perfectly side to side. So that creates this L shape. You guys see this L shape here? It creates this L shape. So that's what right angles look like. Right angles always make this L shape, all right? And they always move 90 degrees, meaning that's a quarter of a turn. If you remember our last lesson, we kind of talked about turns, right? So if you turn a quarter away, so if you were, this is 90 degrees, right? If you kept turning again, this would be 180 degrees. Okay, if you started here and you turned all the way here, that's was it 270? Yeah, 270. If you turn all the way around and go back to the same place you started, that's 360 degrees. Okay, so 90 degrees looks pretty much just like this L here. So a rectangle has 4 of these 90 right angles, 90-degree angles. If we looked here, we can see that there's 1 right angle, 2, 3, and 4. Okay, so that's what makes a rectangle a rectangle. First, it has to have, first it needs to be a parallelogram. The sides need to be parallel to each other, and it has to have 4 right angles. All right, so we have 1, 2, 3, 4 of these L-shaped right angles. So that's what makes a rectangle a rectangle. If you get, I know it's kind of confusing. Don't worry if you're not getting this. Okay. I don't like the way Becca teaches this, but we'll get through it. All right. The next quadrilateral we have to go over. This is a square. So what makes a square a square? Well, a square is a rectangle with 4 equal sides, meaning all 4 sides here have to be the same length. Okay. So first it has to be a rectangle, and the rectangle has 4 right angles. As we can see here, a square has 4 right angles, right? 1, 2, 3, 4. It makes these perfectly, these perfect L shapes. Okay. So is this a right angle, guys? No, right? Because it's not making an L shape. This looks more like a V. All right. Anything that looks more like a V, it's not any angle that looks like a V shape. It's not a right angle. Right angles have to be a perfect L shape like this. All right. Okay, this is more like 45 degrees. Okay. So not only does it have to have 4 right angles, all 4 sides have to be equal. Has to be the same length. So if this was 3 feet, then this side also needs to be 3 feet, and this side needs to be 3 feet also, and this side also needs to be 3 feet. All right. You might be kind of confused. Like you probably never thought of squares as also rectangles, but remember, rectangles are just any shape with any parallelogram. So if it has any 4-sided shape with 4 right angles, is a rectangle. So a square can be a rectangle, right? But this might be a little confusing for you. Can I call this rectangle a square? Okay. Well, we know that it has 4 sides, 4 right angles. But are they all equal sides? Probably not, right? So this rectangle, this side might be 7 feet, and the top and the bottom might be 7 feet, but the sides might be like 5 feet, okay? So it's okay for me to call the square a rectangle, but I cannot call this rectangle here a square because the 4 sides are not the same length. All right, that's a little bit confusing. If you don't understand it, don't worry about it. But that was something that I thought was really interesting. Okay, our next shape here. Let me clean this up. I'm gonna delete most of this stuff to kind of clean it up a little bit. All right, here's our next shape here. This is called a rhombus. rhombus. All right. So what is a rhombus? It's a parallelogram. Again, a parallelogram with four equal sides. So is that right? With four equal sides, yeah. Parallelogram with four equal sides. Okay. All right. So this rhombus here needs to be parallelogram. So opposite sides never cross. Okay. And it needs to have four equal sides. All these sides needs to be the same length. So this could be 4 feet. So if this was 4 feet, then everything else needs to be 4 feet also. All right. Okay. So you might be asking yourself, this sounds a lot like a square. Well, yeah. It's square. I can call this square also a rhombus. Okay. So square is also a rhombus, but this is a rhombus too. All right. So you might be wondering, how come we have two different names, which sounds, might sound a little bit different. But the big difference here is that, remember, a rhombus, a square needs to have four right angles, okay? But on the rhombus here, are these right angles? Do these shapes, do these angles make an L? No, right? Because if I drew it out like this, you see how it looks more like a V shape, okay? I'm not getting a perfect L shape like this, right? So that's the one big difference. So a rhombus doesn't have to have right angles. All right, but it's for something to be called a square, it needs to have right angles. Okay, hopefully that doesn't confuse you guys. So big difference is just rhombus does not need to have 90-degree angles or right angles. Okay. All right, a last one. This is a trapezoid. Trapezoid. A trapezoid only has two parallel sides. So we learned that a parallelogram, the sides need to be parallel to each other, meaning if I extended this side, if I extended this and I extended this, if I stretch it out, these sides should never cross each other. Same thing for the bottom, top and the bottom, okay? If I kept drawing this out here, these two lines should never cross each other. But trapezoid, you can see here that our side up here and down here, these are parallel, because if I stretch these lines out, because stretching them out and out and out and out, further and further out, will they ever cross each other? No, right? They will never cross paths, okay? But can I say the same thing about, can I say the same thing about this side and this side here? Okay. If I stretch these out, if I stretch this line out down all the way down here, if I stretch this line out, you can see that eventually, at a certain point, they're going to crash into each other or intersect. All right. So that's what makes a trapezoid. It has only two parallel sides. All right. So the top and the bottom are parallel, but the left and right side are not. Because eventually, if I extended these lines out, it's going to crash, intersect at a certain point. Okay? All right, so that's a trapezoid. Okay. All right, so that's a lot for you guys to take in, I know. Hopefully, I didn't confuse you. If I did, do not worry. This is just, we're just, for some reason, Becca wants to throw a lot at you at once. But, we'll go over some more of these together. All right. So this is just a general overview. Okay, let's look at our worksheets. Again, up here, if you need some quick reminders of what the shapes are called, you can look up here. Okay, it's pretty good overview of everything we just learned. So all right, let's look at problem number 1. It says place a check mark in the blank if the shape is a simple closed curve. So if you remember, a simple closed curve up here does not have a point of intersect. All right, meaning the shape can never cross each other. All right, so if I had a shape like this, is this a closed curve shape? A simple closed curve shape? No, because right here I have intersection. It crosses paths. Okay, so that's what I'm looking for. All right, and it has to begin where it started to. So this shape right here, is this a simple closed curve? Does any of these lines here cross each other? Let me zoom in a little bit more. Do any of these lines here, does it ever cross each other? No. Okay. If I drew the shape, will I, end where I began? Yeah. All right. So yes, this is a simple closed curve. Okay. So you got to do the same thing for the other ones. So looking for, shapes that never intersect, never cross each other, because something like this is not a closed, what's it called? A simple closed curve, because at this point here, it crosses. Okay, so this is not a simple closed curve, but something like this is a simple closed curve because the lines never cross each other. All right, let's go through each one and just look at it. Okay, so number 2, this is going to be a little bit tricky. All right, so they gave all the names for these shapes. All right, so this square here, I have a square here. So I can label this square as a simple. So you got to look. You're pretty much looking at all these main new keywords that we just learned, like parallelogram. So we'll start from the top. Closed, simple closed curve, polygon, triangle, quadrilateral, parallelogram, rectangle, square, rhombus, and trapezoid. Okay, so looking at all these key words that we just learned, and you're going to label each of these shapes and see if that keyword applies to that shape. So for example, this square here, this square is a simple closed curve, right? Because none of these lines intersect. And we can label it as a polygon too, because it's made out of only straight lines. And we can call it a quadrilateral because it only has 4 sides. Can we label it as a triangle? No, right? Because triangles only have 3 sides to them. This has 4, so I can't write triangle here. I can call this a quadrilateral though, because it has 4 sides and it's a polygon made out of only straight lines. Yep. Can I call it a parallelogram? So parallelogram has parallel opposite sides. Yes, because if I extended these sides, these lines will never cross each other. And can I call it rectangle? Parallelogram of 4 right angles. Yeah, I can, because it has 4 right angles, right? It makes 4 of those L shapes I was talking to you about. 1, 2, 3, 4. Is it a rhombus? Does it have 4 equal sides? Yep, it does. All the sides are 1 centimeters. Is it a trapezoid? Only 2 parallel sides. No, I can't label this as a trapezoid. So if you see here, you won't see trapezoid here because it doesn't have only 2 parallel sides. It has 1, 2, 3, 4 parallel sides, right? Okay, it's a square, obviously, and yeah. All right, so that's where you're going to do. You're going to look at each of these shapes, and you're going to write down what can you label them as. Can you label them as simple closed curve, polygon, triangle, quadrilateral, parallelogram, rectangle, square, rhombus, or trapezoid? Okay. So let's do one. We'll do B together. So B, we have this shape here. First thing, can I label this as a simple closed curve? Yes, I can, right? Because because it has sorry, color. So I can label this as a simple closed curve because none of these lines ever intersect or cross each other, right? Okay. Can I label this as a polygon? Is it made up of just straight lines, line segments? Yes, it's just straight lines, right? To make this shape. So I can label this as a polygon. Can I label this as a triangle? Only 3 sides. No, it has 1, 2, 4 sides. So it's not a triangle, it's a quadrilateral, right? Because quadrilaterals have 4 sides to them. All right, so next keyword here. Can I label this as a parallelogram? Does it have parallel opposite sides? Yes, it does. Because these 2 sides here will never cross, even if I kept stretching them out all the way. And the top and the bottom will also never cross, even if I stretch them out. So this is a parallelogram. Is this a rectangle? A parallelogram with 4 right angles. Does it have 4 right angles? Are these angles? Let me zoom in. So are these all right angles? No, right? Because if I see how it looks more like a V shape, okay? Right angles are looking for more L shapes, okay? Something that goes straight up and down. Okay, kind of like steps. Steps have lots of right angles in them. All right. So I cannot label this as a rectangle. Okay. Can I call this a square? No. Okay. Again, there's no 4 right angles to them. Is it a rhombus? Does it have 4 equal sides? Yeah, I can call this a rhombus. And the last one, is it a trapezoid? No, because it has 4 parallel sides, not just 2. So you'll be doing that. So label this triangle. I know this might be a little tricky for you guys. If you're having a hard time with it, of course you can just contact me. We can go over it together. All right. Pretty much look at these keywords here and see if it applies to the shape that it's talking about. All right. These 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 labels and see if it applies to the shape that you're looking at. Okay. All right, let's look at the next page here. Okay, same thing. You're just gonna keep doing what we just did. Write true or false in each blank. Okay, a polygon has 4 sides. If you don't remember what a polygon is, go back to this page here. Polygon. Does it have to have 4 sides to them? Okay. Okay. All right. Let's see. Okay, everything else seems like pretty straightforward. Okay. All right, that's it for today's lesson. All right, I know it's a lot to take in at once, but hopefully you guys have a better idea of how to do this worksheet. Okay, take care.